A warm and a pleasant morning to you all children. I am very happy to meet you this morning after we had a tedious test last week. Children, we are going to see a new lesson today and the name of the lesson is electricity. Electricity has an important place in modern society. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries, and so on. What constitutes electricity? How does it flow in an electric circuit? What are the factors that control or regulate the current through an electric circuit? In this chapter, we shall attempt to answer all such questions. We shall also discuss the heating effect of electric current and its appliances. We'll go and study in detail for electricity. First, let us see about electric charge. A charge is a physical entry which is defined by excess or deficiency of electrons on a body. You all know that in a neutral body, the number of positive protons and the number of negative electrons are equal. Therefore, the net charge is nil. They don't have any charge. But when there is a deficiency of electrons or when there is an excess of electrons, then we say that body is charged. So, charges are due to deficiency of electrons or excess of electrons in a body. A body is said to be negatively charged if it gains electrons. Example, an ebonite rod rubbed with fur acquires negative charge. A body is said to be positively charged if it loses electrons. For example, a glass rod rubbed with silk cloth acquires positive charge. So there are totally two types of charges. They are positive charge and negative charge. Now let us look into the SI unit of charge. The SI unit of electric charge is Coulomb. Coulomb, and it is represented by capital C. The total charge acquired by a body is an integral multiple of magnitude of charge on a single electron. This principle is called quantization of charges. Accordingly, the magnitude of charge on one electron E is equal to minus 1.6 into 10 to the power minus 19 coulombs. So the negative sign indicates it is for electron, where E is the charge, right? Charge of one electron is equal to minus 1.6 into 10 to the power 19 coulombs. If a conductor has n electrons, then the charge on n electrons Q is equal to Ne is a very important formula where Q represents the charge, N represents the number of electrons and E represents the charge of one electron, that is minus 1.6 into 10 to the power minus 19 coulombs. So children, this is a very important first formula that you are encountering. So Q is equal to Ne is the formula for calculating the number of charges when electrons are being given, and you have given with a problem also to solve. So look at this problem. It is a very important problem where it is frequently asked in the board examination. Now let us go to electric current. How do we express electric current? Electric current is expressed by the amount of charges flowing through a particular area in unit time. In other words, it is the rate of flow of electric charges. In circuits using metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time when the phenomena of electricity was first observed. So, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Conventionally, in an electric circuit, the direction of electric current is taken as the opposite to the direction of the flow of electrons, which are negative charges. If a net charge of Q flows across any cross-section of a conductor in time t, then the current I through the cross-section is I is equal to Q by T. So I is equal to Q by T is the second formula that you are encountering in this lesson, where I is the current, Q is the charge, and time is represented by small letter t. Children, this slide enables you to give a clear idea of how to calculate the electric current and its equivalent physical quantities. What is electric current? An electric current is formed by moving charges. What is the definition? An electric current is a measure of the rate of flow of electric charges through a given cross section of a conductor. So the formula is I is equal to Q by T, where I represents current, Q represents charges, and T represents the time taken. The SI unit of electric current is amperes, and it is represented by capital A. Look at the triangle. It gives you formula for any physical quantity of the three letters. If you want to find the equation for Q, just hide Q, then you will get Q is equal to IT. If you want the formula for I, close I. So I is equal to Q by T. Similarly, T can be calculated by the formula Q by I. So the second important formula you are learning, it's a very important formula. Just remember the formula I equal to Q by T. This slide gives you another very important definition, the definition for ampere. How will you define 1 ampere? So what is ampere? We had already seen. Ampere is the SI unit of electric current, where I is equal to Q by T, the formula we have seen. So 1 ampere is equal to 1 coulomb by 1 second. When you substitute the unit for the formula, you will get this. 1 ampere is equal to 1 coulomb by 1 second. When 1 coulomb of charge flows through any cross section of a conductor in 1 second, then the electric current is said to be 1 ampere. So children, this is a very important definition where you have to remember. Now let us see to the other units of same current. So we know that current is expressed by an SI unit called ampere, and let us see to the smaller version of the electric current. The smaller units of current are expressed in milliampere MA and microampere μA. The relation is given by 1 milliampere is equal to 10 to the power minus 3 amperes. Similarly, 1 microampere is equal to 10 to the power minus 6 amperes. Children, when you are solving the problems, if the units are given in milliampere or microampere, that has to be converted into ampere before you solve the problems. Children, look at this problem now. Calculate the current supplied by a cell if the amount of charge passing through the cell in 2 minutes is 240 coulombs. So, what are the physical quantities being given in this problem? Time is given as 2 minutes, where you have to convert it into seconds. So, that will be 60 times 2, 120 seconds. And 240 C is given. Coulombs, the physical quantity for coulomb is charge. So Q is equal to 240 coulombs. So Q is being given, time is given here, and you are asked to calculate the value of current I. So we know the formula I is equal to Q by T. So just substitute the values of Q and T in the given equation. You will get the answer as 2 amperes. Children, look into this problem very carefully. It is a very frequently asked board question. If you pass 500 milliamperes of current through a bulb, how many electrons will pass through it in 5 minutes? So read the question once again, children. If you pass 500 milliamperes of current, as I told you, this milliampere has to be converted into amperes through a bulb, how many electrons will pass through it in 5 minutes? Again, the time given here is 5 minutes. 5 minutes has to be converted into seconds. So what are the physical quantities given in this problem? Current, it is regarded by the letter I. So 500 milliamperes. Convert it into amperes. So divide by 1000. So you will get 0.5 amperes. Then time, it is given as 5 minutes. So change it into seconds, multiply it by 60. So 5 into 60, you get 300 seconds. So you can calculate first the charge Q. Q is equal to IT. So you know I, you know T. So 0.5 multiplied by 300. So you get 150 coulombs. So the total charge flowing in the circuit is 150 coulombs. But you are asked to find the number of electrons passing through the circuit. See how many electrons will pass. So we already know that in 1 coulomb of charge, then it has 6 into 10 to the power minus 18 number of electrons. Therefore, here in 150 coulombs, the total charge is 150 coulombs. So we have to multiply 150 with 6 into 10 to the power minus 18. So this minus is missing here. You have to definitely include it. Therefore, when you simplify, it comes around 9 into 10 to the power 20 electrons. So just children, let us see to the next concept in this electricity lesson, that is electric potential. What is this electric potential? When a small electric charge is placed in the electric field due to another charge, it experiences a force. So, work has to be done on the positive charge to move it against this force of repulsion. The electric potential is defined as the work done in moving a unit positive charge from infinity to that point. So this definition is a very important definition for electric potential. Children, let us see to the definition of the next term, potential difference. The concept of electric potential is closely linked to that of the electric field. A small charge placed within an electric field experiences a force, and to have brought that change to that point against the force requires work. The electric potential at any point is defined as the energy required to bring a unit test charge from an infinite distance slowly to that point. It is usually measured in volts, and 1 volt is the potential for which 1 joule of work must be expended to bring a charge of 1 coulomb from infinity. This word electric potential can be compared with the overhead tank which is placed at the top of your house. So water is being filled with the overhead tank and it is at a higher potential. The tap is fitted at the lower end, and because of the difference in the gravity, you get the flow of water from the tank through the pipe to the tap. Similarly, is this happening with the cell or a battery? Now look at the diagram here. The cell has two ends, one is positive and the negative, and when they are connected it to a bulb, the bulb glows. This is because one end of it is at high potential and the other end of it is at low potential. As the bulb goes on glowing, then it consumes potential from the higher end till the lower end, and when the bulb glows off, it means both the potentials are equal and therefore there is no net charge in it. So batteries lift charge to a higher potential. There is a potential difference because each coulomb of charge has a different potential energy at either end of the battery. So the potential difference is kept by the letter V, and it is also called as voltage. So V is equal to E by Q is the next formula that you are coming to know, where V is the potential difference, E is the energy, and Q is the charge. So when you look at the SI unit, potential difference is also volt, energy is expressed in joules, and charges are expressed in coulombs. This slide gives you the exact formula which is described in your textbook. Potential difference is equal to work done by quantity of charge moved. So potential difference is kept by the letter V, work done is kept by the letter W, and charge is kept by Q. So W is the work done, Q is the quantity of charge moved. The SI unit of potential difference is volt. How will you define 1 volt? 1 volt is equal to 1 joule by 1 coulomb. Now let us look into the definition of voltage. 1 volt is the potential difference between 2 points when 1 joule of energy is used to move 1 coulomb of charge from one point to another. So this definition comes from the equation V is equal to W by Q. There is a problem, a simple problem associated with this same concept. If 50 joules of energy are available for every 10 coulombs of charge, what is the voltage? So V equal to W by Q. W is 50 joules, Q is 10 C. Therefore, the answer is 5 volts. Now, let us see to the instruments that current can be measured with. The name of the instrument that measures current is known as ammeter. What is an ammeter? An ammeter is a measuring instrument used to measure the electrical current in a circuit. Electric currents are measured in amperes. So the model of a ammeter is shown in the diagram here. And what are the types of ammeter we have? We have moving ion ammeters, hot wire ammeters, digital ammeters, integrating ammeters. So like ammeter which measures current, we have another instrument called voltmeter. A voltmeter is an instrument for measuring the potential difference. The model of the voltmeter is shown in the diagram. What is a voltmeter? A voltmeter is an instrument used for measuring electrical potential difference between the 2 points in an electric circuit. Voltage are measured as volts, and the type of voltmeters are analog and digital voltmeters. Children, this is a very important slide which gives the difference between an ammeter and a voltmeter. First point, ammeter. It is used to measure current. Voltmeter. It is used to measure voltage across 2 points. The resistance of an ammeter is low and the resistance of a voltmeter is high. Ammeter is connected in series with the circuit and its accuracy is more. What is this series connection? We will see it later. Voltmeter is connected in parallel with the circuit and its accuracy is less. Changing of range is not possible in an ammeter. Changing of range is possible in voltmeters. For an ideal ammeter, the value of resistance is 0. For ideal voltmeter, the value of resistance is approximately infinity. It is denoted by the symbol A. It is denoted by the symbol V. So it is a very important board question, the difference between an ammeter and a voltmeter. Children, By this, we come to the end of today's learning. Since you have so many new terms in this lesson, I'm not going to take further. Let me take it bit by bit. Today, I have introduced only three new physical quantities. They are electric charge, electric current, electric potential, and the instruments for measuring electric current and electric potential. And we have seen three formulas. The first formula is Q is equal to Ne. So the charge on n electrons is Q, that is equal to N into E. Then current I is equal to Q by T is the next formula we had seen. And for potential difference, V is equal to W by Q is the third formula we have seen. So children, there are many practical problems which are given in your various websites. So just download them and practice the sums. So problems in this lesson are very, very important. So I recommend you can take a white sheet of paper, the physical quantities, its SI unit and its formula and definition. So if you make a tabular column like this, then it will definitely help you to recap at the time of your examination. Okay, children. So that's all for today. We'll meet next week, children. Until then, bye bye from you.